Hello students. So in this lecture of quantum mechanics we will discuss further the simple harmonic oscillator and very important results relating to this simple harmonic oscillator, and we will see how to form the wave functions of this particular potential. So let us start our discussion. In the last lecture we had a claim that when you apply the A plus operator on psi, it gives a state with energy E plus h bar omega. Now let us check this, the mathematical proof of this claim. Now you have your Hamiltonian H that we have defined in the earlier lecture, and that was in terms of those operators A plus and A minus that we define as ladder operators or raising or lowering operators. These are the two operators, A plus and A minus. You can say one is the complex conjugate of the other, and this is physically very important. We will discuss it further, the importance. And A plus minus combined, you can write it like this. And here we discuss the concept of commutators. Why it is important? Because when you are dealing with the operators like position and momentum, it is very essential that the order in which the operators are applied, that is, that ordering or that sequence matters a lot. So you have to be careful in applying these operators. This is what we saw in the last section, and we were able to find or to write the Hamiltonian in terms of this A plus and A minus, and this was our Hamiltonian, A minus A plus minus h by 2, or you can change the order, A plus A minus plus 1 by 2. And the commutation of A plus and A minus is equal to 1. You can evaluate this yourself, and if you find any difficulty, you can tell me in the comment, I will show you. Because that is all about multiplication and division, so I don't think it is very difficult. And this was the Schrodinger equation in terms of these operators. Now, we had the claim that this kind of an operation, if you apply A plus psi, then it gives a new state with energy E plus omega. Now H A plus psi, A plus, it is not A plus psi, we are not adding A and psi, this is actually A subscript plus a subscript. So be careful. So you write the Hamiltonian in the above form with A plus A minus plus 1 by 2, and this is your wave function. Now what you do, A plus A minus, you multiply this A, but you multiply this A plus here, and you have to be very careful regarding the orders, because these are operators. So what you are doing here is A plus A minus, and you are taking this A plus here, so it is A plus, and this is 1 by 2, a scalar or a number, so it is A plus, simply A plus is here. Now what you have to do, we are doing here, we are taking this A plus out, okay, this, we are taking this A plus from this side and A plus from this side. So A plus is here, and now you are left with A minus this quantity, A plus 1 by 2, sorry, plus 1 by 2. Let me erase this, plus 1 by 2. So we are left with this. Now you have to evaluate this quantity, and you can make of the use of this commutation relation. A minus commutator, we write the commutator in square brackets. I will discuss in detail the commutator algebra, and it is equal to 1. So A minus A plus, when you break this commutator, minus A plus A minus is equal to 1. So this A minus A plus, it will be 1 plus A minus. So you can, for a minus a plus here, you can write this thing, this equation here, and it becomes a plus a minus plus 1, this thing, and plus 1 by 2. Now you observe carefully that h bar omega a plus a minus plus 1 by 2 is the Hamiltonian itself. We had defined the Hamiltonian as h bar omega a plus a minus plus 1 by 2. So this quantity, this one plus this 1 by 2 is the Hamiltonian itself, and there is a one extra term. So you can write it as a plus h bar omega psi. So this is a plus e plus h bar omega psi. Hamiltonian is the energy. So what we observe, that operating a plus once, it takes you to a new state whose energy is E plus h bar omega. That is why it is called raising operator. It is raising the state from one state to a higher state. If this is a ladder, you are applying a plus here, you are going to this state, E plus h bar omega. That is why it is called a ladder operator. This derivation can be found in most of the textbooks. There is an alternative derivation that is described in many of the textbooks, so I have described it here. But I will suggest you to go with this derivation because the things are more clear here. Or if this one satisfies you, or if you find this alternative as short, or it is less tedious, you can as well go with this. There is no problem. So what we have seen, that the a plus operator when acts on psi produces or raises the energy, or you can say produces a new state. I am writing in short, try to understand, concentrate on the language. A new state with energy E plus h bar omega. See, this h bar omega is always there. By the same analogy, we can also check for a minus, that if we apply a minus, it will reduce the energy by h bar omega. So a plus and a minus are operators that raise or reduce, or in most of the textbooks the term used is lower, reduce or lower the state energy. Means a plus takes you to a higher energy state, E plus h bar omega, and a minus takes you to a new state, E minus h bar omega. A minus is taking you down the ladder. If this is the ladder, a minus is taking you down. If this is the ladder, a plus is taking you up. This is the concept. That is why they are said to be raising and lowering operators and ladder operators, because they are doing this in steps. For a diagrammatic representation, you can see the book by Griffith. A very good description is given there in that book. And in that book, in Griffith, a very interesting diagram is also there. A cat who is riding a ladder. Cat is very significant in quantum mechanics because Schrödinger was very scared of cats, and he tried the cat in a box problem because there was a relation with cats with Schrödinger's life. So you can see this diagram in the book by Griffith, very good diagram, very clear diagram, that a minus is taking this cat to lower energy state, and a plus, as you go on applying a plus, it is taking to the higher energy states. So this is the job of the ladder operators. Now in concerning with ladder operators, we have another very important operator that is called the number operator, and this has a equally rich physics and philosophy both. I will discuss both in some other lecture, but for the timing let me tell you the academic content. With a plus and a minus, we define a number operator, and this is very significant in quantum mechanical problems. Number operator, and this number operator is defined as a plus a minus product, and this is equal to the complex conjugate. This is called number operator. Number operator. If you evaluate this quantity, you will get interesting result, but let me tell you the more important thing, the most important result regarding this. That if you take the commutation of n and a minus, it will produce a result minus a minus, and the commutation of n with a plus will produce a commutation of a plus. This is a very important result. You can see the derivations, or you can calculate this using these expressions. I have defined these expressions. You can calculate this, and if you find any difficulty in calculation, then you can tell me. Now the most important thing that we have seen many operators here and many algebraic tricks. The next thing, the most important thing that is still lying, that we still need to discuss, is what is the ground state and what is the wave function of the simple harmonic oscillator. We haven't reached that state till now, so it is very important. So after having discussed all these things, if someone asks you, see, what is the ground state of simple, what is the ground state wave function? What is the ground state wave function? Wave function of simple harmonic oscillator in quantum mechanics. Because that is the most important thing. Schrodinger equation solution means you have to find out the wave function. Now how to find this? The answer to this question is very easily obtained if we make use of these operators. The ground state wave function, the ground state wave function can be found if we consider the use of a plus and a minus. I am writing a plus and a minus, but the most important role or the key role is played by the a minus operator. Key role is played by the a minus operator. Now try to understand, when you are applying a minus, it is taking the cat down the ladder. It is taking you step by step down the ladder. So it is, if you are in a state psi and you apply a minus, you will go to a state psi 1, which is less than psi, it is less in energy than psi. Again you apply a minus to psi 1, then it will take you to psi 2. This means you are on a ladder and you are getting down. There will be a limit. There will be a state which is the zero state from where you started climbing the ladder. What I intend to say is that, suppose this one is the ladder and you are on the top of the ladder. You apply a minus, you are coming to this step, then you are applying a minus, you are coming to this step, then you are applying a minus, again you are coming to this step. Now what after this? After this state, the ladder ends, you are on the ground. So from top you are coming to the lowest state. Now what is this lowest state? What will happen if we go on applying the lowering operator A minus repeatedly? This may take you to a state which is less than 0, but it is impractical, it is totally absurd, because climbing down the ladder you will reach some ground, you will not go underground. It is not so. At some point the lowering operator, it will fail. Why it will fail? It will fail means that A minus, repeated operation of A minus will take you to a state which will not be normalizable. The repeated application of the lowering operator A minus will take the system to a so-called lowest state. Lowest state means this operator means some kind of a formula, some kind of a machine, some kind of a device that is taking you to a new state. At some stage, A minus will fail. Now A minus will fail. What does this mean? Fail means it is not something which is a negative statement. It means that after repeated applications of A minus, a stage will be reached, stage or state will come that will not be normalizable, and we know that normalization is a very important criteria for a well-behaved wave function. I have told you in the previous basic lectures that it should be normal, square, integrable, normalizable. So this means that suppose you are applying the A minus operator and you reach a state psi naught, and when you have applied A minus, it is producing 0. It cannot produce negative states. It is absurd that you are climbing down the ladder and you are going underground. You have started climbing the ladder from a 0 state, from a 0 level state. If you still have a difficulty in understanding, concentrate on what I am saying, that when you define potential energy, you define potential energy with respect to a level. Potential energy with respect to a state or a level where it is 0. You are defining this is as 0 potential energy, then you are going to some height h and you are saying that my potential energy is mgh. This mgh is with respect to this level 0. So when you are getting down, you are coming down to this 0 state, you are not directly going down to the negative state. This is the concept. This means at a certain stage when A minus is applied, this is going to produce 0. This is the failure of the A minus operator. Now from this we can evaluate this A0. A minus is 1 by root under 2 h bar m omega plus IP plus m omega x psi naught equal to 0. Now you replace P by its operator form 2h bar m omega I d upon dx plus m omega x psi naught is equal to 0. This will come this side and it will be 0. D upon dx plus m omega x psi naught is 0. Now this equation has to be evaluated and it is not very difficult to evaluate this. It is not very difficult to evaluate this. You can evaluate this d psi naught upon dx, and it is there is an important step here. I want you to notice that step and tell me in the comment section if you wish to know that. And it is minus m omega x psi naught. This is the equation. Sorry, IH bar it is, minus IH bar. So H bar will be here, plus IH bar. It is A minus, so it is plus. Now this is what you have, and you can evaluate this integral. It is not very difficult. You can evaluate this differential. What will you do? You will do d psi naught upon psi naught minus m omega x by h bar dx. So psi naught will be something exponential in nature, exponential in form. It will be something a constant e to the power minus m omega x square by 2, because dx is x square by 2, x square by 2 h bar. So this is the ground state. You can see it is an exponential equation. It is an exponential equation. So this is your ground state. Now what is the energy of this state? And this is the most important thing that you are going to study about this simple harmonic oscillator. The next question is, what is the energy of psi naught? I am writing it 0 a e to the power m omega x square by 2h bar. How will you find the energy? You will put this equation psi x in the Schrodinger equation that we had defined. H bar omega a plus a minus plus 1 by 2 psi naught is equal to E psi naught. And then what will you see? Again you will have to apply the operators. We use h bar omega a plus a minus plus 1 by 2 psi is equal to E psi. We have to find this psi, and in place of psi we are going to put this equation and use the fact that, and remember these are operators. You have to be very careful, these are operators. A minus psi naught, this is psi naught, this is psi naught. A minus psi naught is 0. So you have to make use of this, and what you find, that energy of this oscillator, because when psi naught will be here, let me describe this, otherwise I don't think it will be clear to you. So what you are doing here, just see carefully, h bar omega a plus operator a minus psi naught plus 1 by 2 psi naught is equal to E psi naught. We are using h psi is equal to E psi. This quantity is 0, so it is h bar omega 1 by 2 psi naught, and it is E is equal to E into psi naught. Psi naught cancel in the language of crude mathematics. And this is for your understanding, of course. So E is equal to 1 by 2 h bar omega. E is equal to half h bar omega. Omega is the frequency, h bar is the Planck constant, and this is a very fundamental physics. The lowest energy, the lowest state has a finite amount of energy, because omega is root under k by m, it is not 0. So the lowest state of quantum mechanical simple harmonic oscillator has energy half h bar omega. This is the most significant result that you are getting in quantum mechanics, perhaps for the first time. This is the lowest step of the ladder. If this is the ladder, this is the ladder, This is the lowest step. You are starting to climb up the ladder by applying A plus repeatedly on this step. Again A plus, again A plus. You are climbing this ladder from here, psi naught. And this step, and if this is the ground, this step is above the ground by half h bar omega. This is the thing that is being conveyed. This is the information that is being conveyed in this equation. That the lowest step is above the ground by half h bar omega. Now any energy of this step 1, step 2, step 3, step 4, all this energy will be added with 1 by 2 h bar omega. So psi nx, any n value, n equal to 1, 2, 3, 4, it will be a plus, because you are rising up the ladder. How many times you are applying the plus operator? A plus x, and the n will be m plus 1 by 2 h bar omega. H bar omega. So what we conclude here? We apply repeatedly plus the raising operator. The raising operator to psi naught x. Sorry, psi naught x, to rise up to higher states. The energy of the lowest state is 1 by 2 h bar omega. So if you put n equal to 0, you are getting this state psi 0. N equal to 0 means psi 0. And your energy will be E0 will be 1 by 2 h bar omega. Now what is the difference from other situations? In the particle in a box, what you observe that n cannot be 0. Particle in a box, n cannot be 0. Here n can be 0. There was no n in the free particle. Particle in a box, we have n square, pi square, h bar, something like that, energy. Sin n pi x by a wave function. N cannot be 0 there, but here n can be 0. We will discuss the physical significance of this result in the coming lecture. So for the time being, think on the topic, read the books, watch the videos, and please like, share and subscribe. And if you have any question, you can tell me in the comment section. Thank you.